revision lesson of mechanical systems in control and also structures. And it's a revision for term 1 work. And today we'll be focusing on structures, frame structures, cell phone towers, strengthening of frame structures. Remember, it's a revision of term 1 and 2 work, structures, systems and control. And today we do structures. Yesterday, when we were doing levers, remember we looked at how the hand can be a third class lever. I looked at that because when I looked at the fulcrum being in the middle in that illustration that we had on our slides yesterday, and the effort was here, that made me see the arm that was illustrated in that diagram as a first class lever. But I want to bring to you this illustration. This one is better. If you can be asked to classify this lever, you would correctly call it a third class lever. Because there in the middle, you see the effort. The effort is not here, but the effort is here. Now, this is the load. This will be your load. The effect will be your load. So, just to correct the classification of the lever, let us look at this diagram. It gives us better understanding of why we would say the arm is a third class lever. The fulcrum is right here, and the effort is here, and the load is there. Then this is correct. But if we say the effort is here, the fulcrum is here, and the load is here, that makes it a first class lever. Okay? I hope that really made you understand the classification of the arm. But going forward now, we are not doing levers today. I only wanted to correct the classification of the arm as a third class lever. All right. Now let us move to frame structures. Frame structures are used for support. Frame structures are used for support. Okay, now what you see here is frame structures supporting. Here, the electric pylons are supporting, they are holding up these cables. These cables are transmitting electricity. So transmission can never happen without this, the support of the frame structures called electric pylons. You see a windmill is also supporting this structure that will be interacting with the wind so that there will be water that will be pumped into that little reservoir there. Now, this frame structure is upholding, supporting the pump. Okay? Now, our term 2 project should be the cell phone tower. We are not going to do projects, but we want to see the cell phone tower as a structure. Okay, although we are not going to make it, I just wanted to bring it in so that we understand it as a structure. Now, this cell phone tower, it comes in different shapes, or it has different types. So we have brought in these different shapes of cell phone towers. You have this first one that looks like a tree, a big tree, okay? And so does the second one. Also, it does look like Tower B, It looks like a tree. And then there's Tower C. Tower C is a pole, and then it has hoisted that cell phone tower, the cell phone unit, the transmission unit for signal, but it is held down by some ropes, supports, or guys. And then Tower D is a steel frame structure, and it is upholding that unit which is used for signal, the satellites and everything. And there's Tower E, another frame structure, and so is Tower F, another frame structure of a different design. But you must note their bases are different. Okay, this one is mounted into the soil. This one even has a bigger concrete base, as maybe if I can say some foundation to mount it. This one is being supported by ropes or guys. And another one has a very broad base, concrete base, to make it firm. And this one, its structure is giving it, it has a broad base. So the shape of the broad base is giving it more support, and it is making it firm on the ground. And Tower F, like Tower C, is supported by ropes which are anchored into the soil, and we call them guys. Now we are going to look at the different designs and their reasons. Right. I want you to type the answers to these questions in your chat. Why do you think Tower A was designed to look like a tree? Answer these questions as in 1, 2, 3, giving the answers like that. Why do you think Tower A was designed to look like a tree? Okay. Tower A is designed like a tree. You saw that Tower C has cables. If I can take you back to Tower C, there's Tower C. It has cables, these cables. And Tower F also, okay? So when you look at this question, why does Tower C have cables while Tower D has no cables? Let us look at Tower D. There's Tower D. Tower D has no cables. Instead, Tower D has a slab, a concrete slab. Why is that so? Give your reason. Okay. Which of the towers on the previous page has the widest base? Why was it designed to have such a wide base? Which of the towers do you think is most unstable? Why do you think so? Okay, let's see. Let's look at your answers. The answer for, oh, I want you to number your answers so that I can see which response it is. Okay, I'll go back to the picture. I'll go back to the picture for you to see. I think you're finishing now. Look at the responses. Junior, which response is this, Junior? Which response is this, Junior? Why do you think Tower A was designed to look like a tree? I think we should rather unmute and talk here. Please raise your hands so that we can unmute you and talk. Why do you think Tower A was designed to look like a tree? Yes, Junior? Yes, Junior?
Ma'am, to stop illegal connection.
To stop illegal connection?
Yes, ma'am.
Let me see if I could take that reason. Do people connect illegally on the cell phone tower? This is not an electricity pylon, it's a cell phone tower. Do people connect illegally on a cell phone tower? I don't know. Do they? Did you think this is an electric pole, Junior? Maybe you're confusing this with an electric pole. It's a cell phone tower for your network. Okay, let's see for progress. Let's see what are the responses for this. Yeah. Okay. The first question is, why does that cell phone tower, the first one, look like a tree? To fit in with the surroundings in the environment. Remember, sometimes technological developments can come in to spoil the look of the environment. So the people who designed this tree cell phone tower, they were thinking of the aesthetics, the beauty of the environment. So they designed the environment. I don't know, Junior, if people do connect legally on cell phone towers. Maybe I just think that you're confusing that with the electric poles, because people do that with electric poles. They get up and then they do an illegal connection. Okay? Right. And then the second question was, why does Tower C have cables while tower D has no cables. Let's just look at the answer for that. C has cables to keep it upright and stable so that it does not fall over. D has a foundation and the base is broader than the top. This keeps it stable, okay? Let us look at D. There is D. It has a foundation. That concrete slab there, it makes it stable so that it doesn't fall. Okay, so it doesn't need these cables. C has cables, but D doesn't need cables. And then, no problem, Divo, no problem. If you look at C, C is also stable because these ropes, these cables are keeping it firm on the ground. Okay. Right, next question. Why will tower A not topple over and fall even when the wind is strong? When you look at tower A, why will tower A not topple over? I think the reason is quite clear. Tower A is anchored into the ground. Okay? Why will tower A not topple over? The reason is that its foundation is underground and it is deep. So foundations are very important when we make our structures. Then the fourth question is, why does tower D have a large concrete block at the bottom while tower E has no foundation? Let's go back and look at tower E. There's tower E. Tower E has no foundation, but tower D has a concrete slab. Okay. What is the correct answer for that? When you look at tower D has a concrete foundation to anchor. E is also firm on the ground because E has a broader base than D. The broad base makes it stable. The broad base makes tower E stable. Okay. Next question was, which of the towers on the previous page has the widest base? Why was it designed to have such a wide base? Okay. When you look at these towers, which one has the widest base? Why was it designed like that? E has the broad base. The broad base lowers the center of gravity and it keeps it stable enough not to fall over. Okay. Which of the towers do you think is most unstable? Look at all the towers here. Which one do you think is most unstable? Who can tell me? Which one is most unstable? Which one is most unstable? C, cables are not as effective as the foundations. Let us look at C. You see, if anyone can come and cut the cables there on C, if anything happens to these cables, this cell phone tower will fall. Okay? And we don't even know what the cables are made of. So it just depends on those cables. And a structure like this, depending on cables, it's its strength or its firmness is not guaranteed. Okay? This one is also supported by cables, but if you can look at it, Tower F, supported by cables, but it has been anchored deep into the soil like Tower A. Okay? Right. The following are different ways to prevent towers from falling over easily. You make the center of gravity low. One way of doing this is to connect the tower to a heavy object at the bottom, like the one that we saw that has a concrete slab. That is a center of gravity. Or you can fasten the tower to the ground with cables, or you can plant the tower deep in the ground like the first and the last tower that you saw, or give the tower a wide base like that tower that you saw with a wide base. Okay, when most of the weight of an object is in its lower part, engineers say it has a low center of gravity. When the most of the weight of an object is in its upper part, engineers say it has a high center of gravity. So when we want to make our structures stable on the ground, we must give them a low center of gravity. When structures have a low center of gravity, they are firm, they will not collapse or fall easily. Low center of gravity. That is one way of making your structures stable. There are many other ways of making your structure stable, but if you lower the center of gravity, I hope you understand what is meant by gravity. Gravity, it is the force that pulls objects downwards to the ground. We call that force a force of gravity. So, because gravity makes objects fall to the ground, we don't want our towers to fall. We don't want our structures to fall. So we give them a lower center of gravity so that they will be stable. Okay, I hope you remember that. Now, answer the following questions on cell phone towers. Look at the sketches of the 6 towers again. For each tower, say which method or combination of methods was used to make it stable. We have looked at the stability of the different towers. Tower A, B, C, up to F. And we have discussed what is it that makes them stable. Okay, let's see. Tower A is made stable by a deep foundation. Tower D, heavy object at the bottom and cables, wider base, heavy object at the bottom, wide base, cables, deep foundation. That is what makes the structures stable on the ground. Okay. Strong foundations help keep towers from falling over. Which towers have foundations underground level to keep them stable? How do the underground foundations differ from each other? If you look at these towers, they have, some of them have underground foundations. Now, how do the underground foundations differ from each other? I want us to talk to me. Raise your hand, we'll unmute you, and then you can talk to me. Number 2, strong foundations help keep towers from falling over. Which towers have foundations under the ground level? Can you see any foundation under the ground? Give me at least one. Which one has a foundation under the ground level? A foundation. That's why I brought the picture here. I want you to see a foundation under the ground. Which one is it? A and B. Okay. Right. How do the foundations differ from each other? There is a foundation on B. Okay, you see a foundation on B. And there is one on A. How do these foundations differ? Under the ground. How do they differ? D is not under the ground, it is on the surface. How do they differ? A is smaller and B is broader. So which one has an advantage? A is smaller and deeper than, yes, and deeper than B. Well, is it deeper? Let me see. Okay. What is the other difference? How can you describe the foundation on B? B is broader. B has a broader foundation. So actually, B is more stable than A because it has a broader foundation. Some of the towers are built from solid concrete or fiberglass. Other towers are metal structures. Now, let us talk. I want you to talk to me. Which one do you think is built from fiberglass here? Do you know fiberglass? Which towers can you say these ones are most probably built from fiberglass? B, Modiehi. B is built from fiberglass. Tower B, Huapili. B, Huapili is built from fiberglass most probably to make those shapes beautiful and make it look real. Okay? Probably A as well. And the others are built from, they are metal. D is metal, E is metal, F is metal. Okay? Now, if you look at these metal ones, why? Okay, Ntivo. Why is it that the steel ones, the metal ones, they are having triangles? What are these triangles for? What are the triangles for? Triangles make our structures stable. So a cell phone tower has to be stable. Yes. It is to make the structures stable. A cell phone tower has to be stable because it is quite a very tall structure. If it is not stable, it can cause accidents, it will fall over, and it will fail its purpose because it needs to hoist this connection device that is put on them. Okay, so for stability, we have those triangles. Okay, so here are your answers. A, narrow, deep concrete foundation. B, wider, heavy concrete foundation. F, a narrow metal foundation. Okay, the metal towers are frame structures, not solid structures like the other ones. Frame structures need triangulation to make them stable. Solid structures do not need that, but solid structures are heavier. Those are the concrete ones, the concrete towers. Those that are made from steel, they need to be triangulated to make them firm. Okay. Now, when we make our structures, it's very important that we understand their qualities of structures, properties of structures. That's why we brought this analysis of structural members. Remember, when we have to build cell phone towers, we must understand the columns and the beams that you are going to use there and other structural members. If you want to do triangulation to make the structures firm, you must know which structural member do we need to put in for triangulation. Which structural member needs to be a column or a beam. Now we need to understand the properties of structural members. These beams and columns, and they are arranged in the order of their strength. Their strength is determined by their interaction with forces. Forces which interact with structures with beams are compression on the top surface of the beam, and under the under part of the beam, this part of the beam is affected mostly by tension. Compression is a pushing force, and a tension is a pulling force. So let us look at these structural members and how they interact with forces, and also to look at their use. This is the H profile. This profile is used as an upright support in columns. For example, in buildings, it resists compression very well, and it does not bend easily. Why? Because it has a broad surface. It has two broad surfaces. The bottom one is broad, and so is the top one. So it can withstand compression. It also does withstand tension as well, because even the bottom part is broad. And then we have the I profile. It is also very strong. It is used for railway tracks. Okay, it is stable because of the broad base. Remember, when we looked at those towers, we said the ones with a broad base are stable because their center of gravity is low. So this is the case in this structural member. Then we have the U. If you turn this around upside down, it makes a U shape. So we call it a U profile. It is lighter than the H profile. It is used to provide horizontal support. For example, in shelves, the chassis of a truck is normally made of U-beams, okay? So when you want to make structures, you must know, what can I use this structural member for? And then this, we call it an angle, an angle girder. It is it has a higher bending strength. In other words, it is resistant to bending than flat strips. It is light and it is often used for cross bracing in structures. This one, it is very resistant to torsion. Okay, we call it the tube. It's a tube, and it is very resistant to torsion. Torsion is a bending, a twisting. It is a twisting force. Then this one is very resistant to torsion or the twisting force. So when we make our cell phone towers, if we were to make the PET, unfortunately because of COVID, we are not going to make the PET, but we are only learning the content that relates to cell phone towers. You would have to choose between these structural members, which ones you are going to use and why. And you must also remember their heaviness. You wouldn't want to place a heavy structural member on the top part of your cell phone tower, because now that would have implications as far as gravity is concerned. So you want your gravity center to be lower. So you are going to put all your heavy structural members at the bottom, also to make your structure or cell phone tower to be stable on the ground. So when we strengthen our cell phone tower or our frame structures, we use triangulation. Triangulation is, it involves the use of triangular shapes to give stability to structures. We want our cell phone tower to be stable, so we are going to make triangles in it. It relates particularly to pinned or hinged structures. It's usually these types of structures, they offer no resistance to bending movements when a force is applied, okay? We said structures react to forces. So when you are using triangulation, you must make it in such a way that the structure is resistant to bending. Members trying to resist bending do not need to be strong. Okay, so that is triangulation. What you see in this truss here, this is a bridge truss, is what triangulation is. You sometimes see this kind of triangulation at the back of your door. I know the doors at your home are very fancy now, but sometimes in your classrooms, you do see this on the door of your classroom. That is to hold together those structural members that make your door and to make your door firm, because you open and close your door at all times. And another way to strengthen structures is bracing. When you can look at this structure here, this structure is not firm. If I can touch it on this corner, if I apply force on this corner, it bends. And to prevent this bending, I must do cross bracing. Okay? So this is bracing. This is bracing. If I apply another member there, that will be cross bracing. Why do we do bracing? We are preventing this bending. We are making our structures firm. You see, this structure is not firm. When you touch it, there it changes shape. So to prevent our structures from changing shape, we introduce bracing. Another feature that we add to strengthen our structures Hi. Hi, my darling. Thank you. Yes, I'm greeting one of my students here, a daughter of my colleagues, of one of my colleagues. This is bracing. It prevents the instability of the structure. But then you can also strengthen the structure by introducing gussets. Gussets are triangular plates that are put at the joint of two structural members. And they are usually metal plates. So that is what we call gussets. When you can look at your roof truss, you will see these gussets. They are used to make the structure stable and they are used to strengthen the structure. When you make your cell phone tower, you need to use this where you join different structural members so that the joint is firm, it doesn't move. Okay, so that is all about structures, and I hope that you have benefited from this lesson. Although we didn't make the cell phone tower, you did explore the content about cell phone towers. I may ask about some of the things that we shared today. That's why I brought it in here. I may maybe in the assessment bring in a picture of these cell phone towers and maybe ask you to analyze the design of these towers. The questions that I gave you today and the possible answers, they can give you a clue of what the assessment may look like with regard to cell phone towers. Okay? I can also ask you about the structural members. The structural members. I can give you a picture and maybe ask you which structural member you would choose to put in a certain position in the structure and why you chose that structural member. Then you have to remember the properties of the structural members. You have to remember this. This structural member, what is its property? The structural member, how I can use it, so that if in your assessment you are asked to pick a certain structural member for a certain structural position, you will know why you are choosing it. Okay. Any questions, grade 7? Any questions? You need to ask me, because when I do set these assessments, yes, bracing means sideways. You introduce a structure. You introduce a structural member that is going to give, that you are going, let me take you to bracing. There is bracing. There is bracing. Okay. You introduce this structure that you are going to put diagonally in your square or rectangular shape. All right. Let me love you and leave you for today. We'll continue with our revision tomorrow. Our assessments will start on the week of the 13th. So make sure that you revise your work. Take your Sasol Inzalo workbooks and try and revise the content there, do the questions and the answers there. Thank you very much.